Hello students, welcome to this lesson on recognizing and interpreting scatter plots. Please make sure you have the note sheet out and you've got a pencil in your hand. All right, let's begin. A scatter plot uses dots to represent values for two numeric variables. Each dot represents an individual piece of data, which is called a data point. The purpose of a scatter plot is to observe relationships between variables. Observe relationships between variables. So we've got a scatter plot here, okay? So let's have a look at the variables. Along the x-axis, we have average daily temperature measured in degrees Fahrenheit. Along the y-axis, we have the number of visitors, and the topic of this data is beach visitors. So we see a number of data points on our scatter plot. Okay, so this graph, we're trying to observe relationship between average daily temperature and the amount of visitors that visit a beach. Okay, so when you're presented with a scatter plot, there are a number of questions you can ask yourself. What is the x-axis showing? What is the y-axis showing? Are there any clusters of data points? Clusters are groupings of data points. So if we have a look, we can see that there's a cluster here, there's a cluster here. Okay, you can call this a cluster, I guess, or maybe it's not a cluster. Are there any patterns that you can easily see? Example, are the dots moving upwards or downwards or diagonally or horizontally or vertically or randomly? So if I look at this graph, it looks like, I'm going to change colors here, it looks like these data points seem to be following a pattern upwards like this. Okay? So look for those types of patterns. Are there any data points that don't seem to fit a pattern? This is a very important vocabulary word here, an outlier. Okay, so if we have a look at this graph here, there doesn't look to be any points that are really way off of our trend or our pattern. And the last one, does it seem like there is a connection between the two values that are being observed? Okay, so if we look at this data, this scatter plot, we can see that as the daily temperature increases, it looks like the number of visitors to the beach also increases. All right, let's move on to the next part. All right, scatter plots are most suitable when trying to observe and show relationships between two different variables. It is also very useful in identifying correlational relationships. So let's make sure we spell this right. Correlational relationships. We can classify these relationships as positive or negative, another way we can classify the relationship is strong or weak, and finally, we can classify the relationship as linear or nonlinear? Okay, let's move on to page 2. To help make conclusions, we can draw what's called a line of best fit. Line of best fit. Okay? This is a very important concept. If the cluster of data points follows a general line, then this is classified as a linear correlation. So if the cluster of data points follows a general line, or the line of best fit, then this can be classified as a linear correlation. So if we go back to our scatter plot example here, what I drew earlier, before I introduced the vocabulary, was a crude version of a line of best fit. Okay? And if the data points, the points kind of follow that line, then we have a linear relation, okay, or a linear correlation. So in this case, there is a linear correlation, okay? If the cluster of data points does not seem to follow a general line, example, if it is a different shape, then this is classified as a, hopefully you can predict what I'm going to write here, non-linear correlation. Or no correlation. Okay? So because in our previous scatter plot, the data points seem to follow that line, there is a linear correlation. All right. Next point. Oops, sorry about that. All right. If a line of best fit goes upwards, then this is considered a positive correlation. So if the line of best fit goes upwards, then this is considered a positive correlation. So if from our previous example, we know that the line of best fit goes upwards. So this would be considered a positive correlation. If the line of best fit goes downwards, then it is considered a negative correlation. If the line of best fit is fairly steep, upwards or downwards, then it is considered a strong relationship. And if the line of best fit is gradual, upwards or downwards, then it is considered a weak relationship. Okay? All right, the couple of practice questions below the note, I'm going to walk you through the first one, and that should model the other two as well. And then there are a few questions on page 3. Okay? So try drawing a line of best fit over the graphs below and classify each scatter plot under each graph with as many descriptions as you can. All right, so in scatter plot 1 with the green dots, it definitely looks like the line of best fit could be drawn in an upwards motion. So on your sheet, could you take a ruler and could you just draw in lightly a line of best fit, kind of that cuts through the majority of those dots? Okay? So do you remember the vocabulary from the note? So we definitely have a linear correlation because it seems like most of the dots seem to follow this pattern, this line. Okay, so for the first thing, we can write a conclusion that we have a linear correlation. Now again, we want to classify this scatter plot with as much new vocabulary from the note as possible. Okay? So we know that we have a line of best fit. So we can include that. Line of best fit. And then we could put a check mark. Because the line of best fit is going upwards, what type of correlation would we have if the line of best fit is going upwards? This would be considered a positive correlation. Okay. Now, would you say that this is steep or gradual or in between? Now, if it were steep, I think we'd be looking at a line of best fit that would kind of look like this, right? But it's not really that steep. But if it were gradual, I think we'd be looking at a line that looks kind of like that, which is not really accurate to the line of best fit. So because it's somewhere between steep and narrow, we can't really call it strong or weak. So how about we just call it moderate or moderately strong? Okay, I want you to get familiar with how we can classify these scatter plots using this new vocabulary. So if you can finish example 2 and example 3, and then go on to the questions, number 2 on the 3rd page as well, and then we'll take it up when we see you in class. Okay, grade 8s, thanks for watching. Bye.